Biosafety Cabinets. Learning objectives. The different classes of Biosafety Cabinet or BSC, the operation of a BSC, the precautions to be taken when using a Biosafety Cabinet, and calibration. Biosafety Cabinets. The aim of a Biosafety Cabinet is to provide personnel, environmental, and product protection when appropriate practices and procedures are followed. There are three kinds of biosafety cabinets, class 1, 2, and 3, which were developed to meet varying research and clinical needs. Each class of cabinet provides protection through different configurations of HEPA filtered airflow into and within the cabinets, as well as HEPA filtered exhaust air. The most basic design is intended to protect the product that is handled from environmental or worker-generated contamination rather than to protect the worker. Laminar airflow is such a basic design which provides only product protection. The given image shows a lateral view of the laminar flow cabinet with its parts labeled. A is the front opening through which the product is handled. B, the sash which is lifted at the time of work. C is the supply HEPA filter, and D is the blower which helps in circulating the air. It takes in room air, filters it through a HEPA filter, and then discharges it across the work surface and towards the user. The entire body of air flows with steady, uniform velocity within the designated space with a single direction along parallel flow lines. It is used for clean activities such as media pouring and in molecular laboratory where product protection is critical. HEPA filters. HEPA stands for High Efficiency Particulate Air. It is a mechanical air filter that forces the air through a fine mesh that traps harmful particles. As shown in the image, it consists of a thin, continuous, pleated or folded sheet of boron silicate microfibers with aluminium separators. Biosafety cabinets with HEPA filters provide maximum protection. It may be used as a supply HEPA filter through which filtered air flows into and within the cabinets, or as exhaust HEPA filters through which contaminated air from the cabinet is filtered and then exhausted to the outside. It removes 99.97% of particles with a diameter of 0.3 micrometer or more, thus ensuring microbe-free exhaust air. For safe and optimum performance, HEPA filtration devices must be designed correctly and regularly tested and recertified by qualified personnel. Class 1 Biosafety Cabinet. The given image shows a lateral view of the Class 1 Biosafety Cabinet with its parts labeled. A, the front opening through which the product is handled. B, the sash which is lifted at the time of work and lowered after the work is completed. C is the exhaust HEPA filter, and D is the exhaust plenum, which is a separate space provided for air circulation. The room air is drawn in through the front opening at a velocity of 0.36 meters per second. The air passes over the work surface and is discharged from the cabinet through the exhaust duct. Airborne particles contained in the cabinet are filtered from the exhaust air through the exhaust HEPA filter. Note, there is only one HEPA filter present in this class of cabinet. Advantages. The Class 1 Biosafety Cabinet, because of its simple design, is still in wide use throughout the world. It has the advantage of providing personnel and environmental protection and can also be used for work with volatile toxic chemicals. Disadvantages. Because the unsterilized room air is drawn over the work surface through the front opening, there is no reliable product protection. Class 2 A1 Biosafety Cabinet. The given image shows the front and the lateral views of Class 2 A1 Biosafety cabinet with its parts labeled. A. The front opening through which the product is handled. B. The sash which is lifted at the time of the work. C is the exhaust HEPA filter. D is the rear plenum. E is the supply HEPA filter through which filtered air enters the cabinet. And F is the blower which helps in circulating the air. The room air is drawn in through the front opening into the front grille at an air velocity of 0.38 meters per second. The drawn air from the room and the potentially contaminated air from the cabinet is circulated by the blower through the rear plenum to the HEPA filters. 70% of the air is recirculated back into the cabinet through the supply HEPA filter labeled E, and 30% of air is exhausted by filtration through the exhaust HEPA filter labeled C. Note that there are two HEPA filters in this class. Class 2 A1 type of biosafety cabinet provides personal, product, and environment protection. Class 2 A2 biosafety cabinet. The given image shows the front view of Class 2 A2 biosafety cabinet with the colored arrows indicating the flow of air. It functions similar to Class 2 A1 biosafety cabinets. The contaminated room air, indicated by the green arrows, is drawn in through the front opening into the front grille at an air velocity of 0.51 meters per second. The air drawn from the room and the potentially contaminated air from the cabinet, indicated by purple arrows, is circulated through the rear plenum to the HEPA filters. 70% of the air is recirculated back into the cabinet through the supply HEPA filter, and 30% air is exhausted by filtration through the exhaust HEPA filter to the outside. Note that there are two HEPA filters in this class, and the HEPA filtered air is indicated by blue arrows. Class 2 A2 type of biosafety cabinet also provides personal, product, and environment protection. Class 2 B1 Biosafety Cabinet. The given image shows the front and lateral views of Class 2 B1 Biosafety Cabinet with its parts labeled. A. The front opening. B. The sash. C is the exhaust HEPA filter. D is the supply HEPA filter through which filtered air enters the cabinet. E is the exhaust plenum. F is the blower which helps in circulating the air, and G is the HEPA filter for supply air. The room air is drawn in through the front opening into the front grille at an air velocity of 0.51 meters per second. The drawn air from the room and the potentially contaminated air from the cabinet is filtered through the HEPA filter labeled G and circulated by the blower through the exhaust plenum to the HEPA filters. Only 30% of the air is recirculated back into the cabinet through the supply HEPA filter labeled D, and 70% is exhausted by filtration through the exhaust HEPA filter labeled C. Note that there are three HEPA filters in this class. Class 2 B1 type of biosafety cabinet provides personal, product, and environment protection. Class 2 B2 Biosafety Cabinet. The given image shows the front view of Class 2 B2 Biosafety Cabinet with the colored arrows indicating the flow of air. The contaminated room air, indicated by the light green arrows, is drawn in through the front opening into the front grille at an air velocity of 0.51 meters per second. The drawn air from the room and the potentially contaminated air from the cabinet, indicated by purple arrows, is circulated through the rear plenum to the exhaust HEPA filter, through which it is completely filtered out to the facility exhaust system. Contaminated room air supply, indicated by dark green arrows, is drawn in and filtered by the supply HEPA filter and then discharged onto the work surface and product. It is to be noted that 0% of the air is recirculated and 100% is exhausted in this class of biosafety cabinet. Class 2 B2 type of biosafety cabinet also provides personal, product, and environment protection. Class 3 Biosafety Cabinet. It is quite different and more complex than the other classes of biosafety cabinets, as it is used to handle risk group 4 organisms. The given image shows the front and lateral views of Class 3 Biosafety Cabinet with its parts labeled. A is the glove port with arm-length gloves through which the products will be handled. B is the view window. C is the double exhaust HEPA filter. D is the supply HEPA filter through which filtered air enters the cabinet. E is the double-ended autoclave or pass-through box through which requirements may be taken in and out of the cabinet. And F is the chemical dunk tank. Note how this class of biosafety cabinet does not have a front opening. The air circulation is fairly straightforward. It enters through the supply HEPA filter labeled D and is discharged through the double exhaust HEPA filters labeled C. The cabinet exhaust needs to be connected to the building exhaust system. 0% of the air is recirculated and 100% of the circulated air is exhausted. Differences between Class 1, 2, and 3 biosafety cabinets. They are differentiated based on the face velocity, the airflow pattern, and exhaust system. Face velocity is the measured air velocity at the inlet or front opening. Class 1 has a lower face velocity and 100% of the air is exhausted out through a hard duct which is firmly connected without any opening. Class 2, A1 and A2 have a similar airflow pattern with 70% air recirculated and 30% exhausted. The differences are the face velocity, which is higher in Class 2, A2, and that the exhausted air is vented outside in Class 2, A2. Class 2, B1 and B2 have the same velocity. However, in Class 2, B1, 30% air is recirculated and 70% is exhausted, whereas in Class 2, B2, 100% of the air is exhausted. Class 3 is a closed biosafety cabinet and 100% of the air is exhausted. Differences between the biosafety cabinet and laminar flow hood. Biosafety cabinet Class 1 protects the person and environment from biohazard agents by drawing in the air from the room. And biosafety classes 2 and 3 additionally protect the sample by dispersing filtered air over the countertop with the samples. While the laminar airflow hood protects the products from contamination using filtered air, but does not provide personnel or environment protection as the airflow is directed towards the worker and the room. Points to remember before operating a biosafety cabinet. Turn on the lights and air switch. Check the intake and exhaust grills for any blockage. Disinfect the entire area with 70% ethanol except the front shutter or with UV light for 30 minutes. Lift the sash or the viewing window and place it at a height of 8 inches. Place everything needed at least 4 inches inside the work area. The work should be arranged from left to right as dirty to clean. Points to remember after operating a biosafety cabinet. Decontaminate the surface with appropriate disinfectant. Cover the tray of disinfected pipettes and glassware. Allow the cabinet to run for at least 30 minutes with no activity to allow time for all airborne contaminants to be purged from the work area. Remove all equipment. Wipe down all interior surfaces with 70% alcohol. Controls and indicators of a biosafety cabinet. There are light switch controls for fluorescent lamp in work area and a switch for ultraviolet light. There is a static pressure gauge, magnetic. It measures the differential pressure across the supply filter. It provides an indication of filter loading. That is, as the filter becomes dirty, the resistance of the filter increases, increasing the reading on the static pressure gauge. When the reading increases by 50%, the cabinet airflow should be checked with an anemometer and the filter be replaced if inefficient and overloaded. Precautions while using a biosafety cabinet. Location. It must be placed away from potentially disturbing air currents. There must be at least 30 centimeters clearance behind and on each side of the cabinet, and a clearance of 30 to 35 centimeters above the cabinet for accurate air velocity measurement. Operators. They must maintain integrity of the front opening air inflow when moving their arms into and out of the cabinet. Manipulations must be delayed for 1 minute after placing hands and arms to allow the cabinet to adjust and to air sweep the surface of the hands and arms. Placement of materials. The front grille must not be blocked with paper, equipment, or other items. Any blockage of the cabinet intake grille will disrupt the airflow pattern in the work chamber, leading to airflow turbulence. Aerosol generating equipment should be kept towards the rear of the cabinet. Operation and maintenance. Cabinets should be turned on at least 5 minutes before beginning work and after completion of work. UV lights. The cabinet must be cleaned regularly to remove any dust and dirt that may block the germicidal effectiveness of the UV light. Its intensity must be checked when the cabinet is recertified to ensure that light emission is appropriate. Eyes and skin must be protected from inadvertent exposure. Open flames. They should be avoided as it may disrupt airflow patterns. Microburners are preferred. Other precautions are certification, cleaning and disinfection, decontamination, and personal protective equipment, which must be worn when using a biosafety cabinet. How do we know whether the HEPA filter is working? The biosafety cabinet has a gauge with a red colored oil which has a higher viscosity. The normal value is from 0 to 15. If a value greater than 15 is shown, then it means that the HEPA filter is clogged. Calibration. It must be done once in 6 months to detect deterioration of airflow and filter compromise. Some of the tests performed are air velocity test, HEPA filter particle count test, dispersed oil particulate or DOP test. Calibration by air velocity test. It measures the flow velocity of airflow in a biosafety cabinet or laminar airflow. The equipment used is an anemometer, which is the device used for measuring air velocity and air volume. Calibration by particle count test. This counts the individual particles using scattered laser light. The equipment needed is a metone particle counter. 5 locations within the hood are tested, and particles of different sizes such as greater than or equal to 0.3 micrometer, greater than or equal to 0.5 micrometer, or greater than or equal to 5 micrometer can be measured. Calibration by dispersed oil particulate test. The integrity of the HEPA filter is tested through the introduction of particulates. Oil is dispersed as an aerosol into the upstream flow of the filter, while the number of particles detected in the downstream flow is measured using a calibrated photometer. The whole filter face is tested for any damage or leak. The equipment needed are a check photometer and an anemometer. How to demonstrate airflow in a biosafety cabinet. There are different methods to do so. A few examples are listed here. Place a tissue paper on the front grill. The tissue is pulled in. 2. Light a matchstick. The flame will be directed downwards at the front and rear grill. 3. A smoke pen. The direction of the smoke will be the same as the direction of the airflow within the hood. 4. Agarbatti. it has the same effect as a smoke pen. To summarize, we have looked at the function of a biosafety cabinet, which is to provide product, personnel, and environment protection. We've looked at the different classes of biosafety cabinets, their working mechanisms, and the differences between them. Laminar airflow cabinets, their uses and their differences from a biosafety cabinet. The steps to be taken before and after operating a biosafety cabinet. Precautions and the different tests for calibration of a biosafety cabinet. Thank you.